Thank you once again for his presentation. And the next presenter will be Farhad Bolouri again on behalf of his team. And presentation will be about prediction of runoff using artificial neural networks, ML, regression, and Arima model. For a case study of NIR by Regression.
Yes, this research named prediction of runoff using artificial neural networks, ML, regression, and Arima model. The case study River, written by Dr. Yusuf Kasım and Professor Hüseyin Gökçekuş, and because he could not attend this today to this conference, I present behalf of him. You see table of content, introduction, aim of study, study area data, machine learning models, Arima, ML, results and discussion and conclusion. As an introduction, climate change is an important factor for strategic resource management in arid and semi-arid countries. Recent studies have shown the adverse effects of climate change on both resources, thus investigating the impact of climate change on the hydrological cycle is essential for hydrology development. Several studies have concluded that climate change is the main indicator related to the change in runoff in the basins or catchment area. Accordingly, the prediction of the quantity of water available in a basin over a larger period is considered an essential topic of scientists and engineers for centuries. Additionally, the analysis of runoff is very important for predicting floods and drought. Moreover, runoff modeling is a versatile tool to designing and operating the various components of water resources projects and water resources planning and management. It also helps to reduce influence and drought and water resources issues. Recently, several empirical models of runoff series such as machine learning models and mathematical modeling are developed to construct a long-term runoff forecast models. Aim of this study is this one. In this study, for empirical models, namely feed-forward neural network or FFNN, and cascade feed-forward neural network or CFNN, autogressive integrated moving average or Arima, and multiple linear regression MLR are developed to predict the runoff at Farhad River in Lebanon. And the massive local methodological data, including maximum temperature, minimum temperature, wind speed, solar radiation, rainfall, and soil moisture, are utilized as input variables for the models. The study area is Farhad River, the third largest river in the Akkar district of northern Lebanon, has a very important strategic position. It is fed by streams in the mountains. Recently, the heavy rainfall with the snow has led to an extreme flood, which causes some stresses up to the windows of the houses, especially houses built near the river. You see here the map of this river, Mediterranean Sea, Lebanon, and where is that river. About the data, due to the limitation of available the actual data of climate parameters, global methodological data are utilized to understand the influence of geographical coordinates on the prediction of precipitation and predict monthly precipitation using various empirical techniques. In this study, global meteorological data were
O girmedi daha değil. Sadece 3 kişi var. Java
dataset
ve bir.
offers global monthly meteorological data with high spatial resolution, monthly climate, as well as previous the data since the year 1958 to date. The main resources to utilize Terra climate, where the availability of consists long term is monthly maximum temperature, minimum temperature, solar radiation, wind speed, soil moisture, runoff, and rain. About the MLM, are utilized as a tool to describe a complex system. Wide range of ML models are utilized to solve complex problems in a variety of fields. In this study, FFNN and CFNN are developed to determine the runoff. FFNN and CFNN are the most popular artificial neural networks approach for modeling non-linear and complex process in the real world. In this study, the training 70% and testing data 30% of data were used to develop and validate the models respectively. The results of the proposed models are compared with the observed data. The Arima model is very widely used to time series modeling, proposed to by Bugs, Genetics, and Rainsel. The model involves autogracer or AR and the moving average or NA models. The Arima model is very popular and harsher than the other time series models, which is defined by three terms, P, D, and Q. Bugs Genetics algorithms are utilized to finalize the value of P, D, and Q. Here you see the formulates for NLR, and here as the result of discussion, the performance of FFNN and CFNN is compared with the Arima and MLR to evaluate the performance of the proposed models. The value of R squared and the root mean squared error or RMSE are shown in below. You see the maximum R squared is for Arima and the minimum RMSE is for Arima. When your R squared is maximum and your RMSE is minimum, that model is your best model. It is noticed that the maximum R squared value and minimum RMSE were obtained from Arima model, followed by FFNN with a value of 0.8 for R squared and 10.25 for RMSE. Next figure illustrates the time series plots and observed and predicted runoff values in the testing phase. Yes, as you see, the observed FFNN, CFFNN, Arima, and MLR models have the calculated and have the difference between observed and all of these models. As a conclusion, in this study, the ability of FFNN, CFNN, Arima, and MLR models for monthly runoff prediction was investigated. R square and RMSE were employed to evaluate the performance of the models. The results showed that the Arima and FFNN models were suitable for estimating the monthly runoff. Among the developed models, the Arima model presented scientifically better prediction performance based on the value of R2 and or R squared and RMSE. In the future work, various models with various combination of parameters should be investigated to identify most parameters that influence the runoff prediction. Thank you so much for your attention.
Our next presenter will be Mirza Baik, and the presentation title will be Sustainable Stormwater Management Practices for Regression.